Sunday County Fairgrounds. That's out in Henderson, out towards Brighton. Um, so we will, for the information on that, you can go to our website, w0tx.org, click on events, and then Hamfest, and that'll bring you into all the information, where, when, and a map. And uh, also, as you scroll down, our tables, you can buy a table for $13 if you do it ahead of time. You can do it, pay for it via PayPal or credit card, or you can print off the application and mail it. But we're getting short on time here, so I would best to do would be to do it online. And the tables are $13. At the door, they'll be 20, and admission is $6. You do have to have an admission with the table. The table, does not come with an admission, so that's pretty standard with every Hamfest, I think, in the at least in Colorado. And so, if you'd like to get a table, please do so. I think we're going to have a really, really good event. One thing that I'll mention that we only do at Hamfest, and that if you want to, if you're not a member, you want to join the DRC, or if you are a member and you want to up uh, extend your membership, we run a special only at the Hamfest, so you can get 15 months for the price of a year. So 15 months for the price of 12, only at the Hamfest, and we limit that to three years, if you will. So that's a good way to extend your membership and get a little discount doing it. We will have our drawing after Josh's presentation, and it's for $25 gift certificate at HRO. And Jeff will put that in the chat towards the. There'll be a link in the chat towards the end of the presentation. You can go to the chat, go to the link, and put your information there, and then it'll go into the electronic tumbler, and that'll get spun, and it'll pick a pick a name out of there randomly. So that's how that works. You do have to be a member to be eligible for the drawing. And unless there's a question or anything for me, I will get on with our meeting presentation. And hearing nothing, Josh, go ahead. And thank you for doing this. This
Sure.
kind of started with Josh he was at field day and flying his drones, and we got to talking about stuff that he's made uh, for well, different ham radio projects, and so we said, hey, how about doing a presentation? So we appreciate you doing it, and it's all yours. Go ahead.
All right. Let me pull up my screen. Happy to be here. Let's see. I'm just going to share the whole screen so I can jump around different tabs. Okay. Yeah. Well, thanks for having me. Hello, everyone. Like I said, I probably got a little bit of attention at our last field day. I was out flying the drone around trying to get some good aerial imagery and video of some of our towers going up and some of the events of field day. And some people came over to see what the drone was all about, for one, and noticed there was a lot of plastic on that drone, a lot of things, legs or hooks and different types of things that I 3D printed for that drone. And that kind of segued into how I 3D print multiple things for my ham radio, my HT, my one of my truck, and for my dad here as well. So hopefully I can give you guys a little bit of an overview of 3D printing, and happy to go into more detail if you'd like to, but I try to keep it kind of a introductory level for the most part.
That thing at the bottom of the screen that says you're sharing your screen, can you just go ahead and click hide on that?
Oh,
Perfect. You're good to go.
Not a Google Meet person as much.
No worries.
Okay, before I get too far in, just kind of looking back on where 3D printing has been and where it is now. It's really advanced a lot in the past decade, but actually started in the 80s. The very first 3D printer was invented. Um, Back then, as with most computer devices back then, like printers, they were very large. It took up most of a room, and the first commercially sold 3D printer, later in '92, sold for $300,000. So it wasn't something that the average Joe or the Elmer was picking up and doing these tiny little projects with their ham radio. So that was to come later. But as technology advanced, prices even went down. That kind of went down through all this. And 2007 is kind of was a big stepping stone, and a lot of other brands coming online, as well as printers that were made up of 3D printed parts started coming online, which drastically dropped the price of manufacturing the 3D printer. And now these 3D printers can, for the most part, build themselves with the help of the few metal pieces and computer boards and stuff that come along with it. So after 2007, pricing started dropping. 2016, like I said, just 6 years ago, 3D printers finally started getting below $1,000, getting a little bit more affordable to the average consumer. And today, you can go to Micro Center or go on Amazon, and there's many options for under $500. For example, the brand new Creality Ender 2 Pro, it's their smallest entry level printer, $170. So really low cost entry at this point. It's not what it used to be just a short 10 years ago. So cost entry is pretty small. But why would anybody get into this 3D printing? What do you do it for? What I use it for, mostly it's very low cost prototyping. It's things you can kind of print, try out, see if it works or not. And it's most of the time just a cheap filament, a biodegradable plastic that you can throw away or reuse or grind up and use again. It's a chance to put your thoughts into a physical object without having to know how to use all the expensive woodworking tools or metalworking tools, and a huge shop that's assigned with all those things, and a little bit more of a detailed product than gluing something together or cutting freehand. It's also something that you can produce in house. You don't have to wait for something to come in the mail. You don't have to wait for shipping, and if you want something today to figure out how to fix this problem or adjust a plug for one of your radios, you can print it today and have it today. And also, maybe this thing that you're thinking of in your head doesn't exist in the real world. And I know that happens a lot with ham radios. People are developing their own enclosures, their own mounts, their own any type of thing that we feel needs to fit this niche that either doesn't exist, or maybe does exist, but it's way too expensive because it's made of aircraft grade aluminum and it just needs to be this little thing to hold my microphone in the truck. So many reasons why you might justify getting a 3D printer. A couple ham radios themed prints I've done that I was able to grab pictures of. I threw them up here. So the first one, I guess, on the far left and far right is just a mount to hold my little Anytone HD. So it just slides in, belt clip holds it in. It's a retained clip and allows me to put it in my truck, on my motorcycle, on my bike, anything that I have a normal RAM ball mount. I can put my Anytone there now. And it's safe and secure, retained with the belt clip, and I still have access to put DC power cord, to put different microphone adapters to the sides and the top. And that was a file that was available to download. I didn't have to know anything about coding or designing or 3D modeling. The two in the middle are ones that I actually did have to design myself, that those products didn't exist or I couldn't at least find them online. So the bottom one first, I wanted a way to put a remote speaker for the truck radio right in between the uprights of the headrests of my small truck. So you can lift the headrests up and you have those bars. So super simple just to put a loop on the side of both of those. I'm sure many of us have probably done it with washers or 550 cord, but a quick 10 minutes in a 3D modeling program, build these little angle uprights with the exact diameter holes that you need, print it out, and that solved your problem. Similarly, center top, this is actually in Dad's truck. He wanted a good, convenient way to mount the faceplate of his truck radio. And ashtrays aren't what they are used for anymore. So we took the ashtray out, I measured out the bolts to figure out exactly where they needed to be and how it would fit, and went ahead and put this trusty hole right in the center where all of our faceplates can bolt in. And sure enough, fits perfect. Now there's a faceplate that seems to be mounting right where the ashtray used to be. So endless possibilities, and there's just a few here that I've printed recently. So the types of 3D printers out there are at least a dozen different types, but for entry level, they're kind of down to these two. The first one on the left being the most common, fused deposition modeling. That's what you're going to see most people have. That's what I run. It's essentially you're melting a plastic filament, running it through a nozzle, and that nozzle is running on a controlled CNC rig to essentially lay out a pattern, a layer, think like a hot glue gun, and then raising it up a set distance and doing that layer again, building off of each other over and over and over until the final product is built. The one on the right, still layer by layer, but how it does it is actually a bath of liquid resin, and a UV laser actually traces the pattern on a build plate, and that build plate is slowly raised out of the resin bath to build your product upside down. So essentially it's suspended from the build plate. Benefit of SLA resin printers, they're much more detailed, they're finer detailed. The cured resin is a much harder product, and so it won't melt or get soft in hot sun. SLA resin printers are typically used. You'll see them in medical, dental work, those types of things. But for 99% of consumers, myself included, the one on the left, fused s.t.e.m printers is more than enough for what we use it for. So here's a good example. This is an Ender 3, which is what I have. It's a filament printer, some basic controls. Really all you need is a build plate. That's what your object is going to get built upon. You're going to have your hot end, which is Corona here. That's the print head. That's where the melted plastic material is going to come out while this head moves side to side and the build plate moves forward and aft to build your product. And then this whole rig moves up as your product grows, and then a control interface. That's just, you have a computer built in with all of the servo motors and stepper motors. So that's just a place for you to control this printer. So the ways you can be adjustable with s.t.e.m printers is the types of filaments you're going to use. Not only what color, you can use any color you can imagine, as well as gloss or matte or transparent or reflective, but there's also different plastic materials. Polylactic acid being the most common, PLA. It has the lowest melting point, so it's the quickest to melt. It's the easiest to work with. It's the cheapest. Like I said before, it's biodegradable, so when you're done using it, you can grind it up, you can throw it away. It's very easy to work with, easy to print. The settings are pretty standard, and any s.t.e.m printer off the shelf can run PLA. The downside of PLA, like I showed here, the 150 degrees Fahrenheit of glass transition. Glass transition temperature is where your 3D product, your object you printed, starts to get soft. So if you have this thing holding your radio, it might start falling down. You're not going to see 150 degrees too often outside in the air, but if it's something inside of your car where you're in a parking lot, you will definitely get up to 150 degrees. So you might want to find a different option than PLA. Also, being biodegradable means it's not UV resistant. Out in the sun, it will degrade over time. So some other filaments out there that resist temperature better or resist UV better. PETG being the first one. It's just slightly higher, 170 degrees. So still easy to work with, pretty forgiving on print settings. And then the next two, ABS and ASA, are very high strength, UV resistant, very high temperature, but typically also involve toxic fumes. So you need to make sure you have an enclosure, good exhaust fans. You don't want this going while you're sitting next to you on your work desk. So with higher strength comes some other things you need to be cognizant of. Thermoplastic polyurethane, TPU, is another interesting filament. This is actually a soft, almost rubber-like filament that I've used, and after it's printed, it stays this soft rubber. Think like a phone case or an O-ring for a type of enclosure. So something you want it to be soft and stay soft. You can also run TPU through most regular filament printers, and with that comes some other print settings that you have to adjust because now your object is soft and gooey the entire time. But it's another product out there, and there's many others. They have some with wood infusion, so it looks like wood. They have some with tiny bits of copper in it, so it's conductive, so you can actually be printing your own microchip board with conductive lines. There's carbon fibers. There's ones you can post treat in the oven. So the list goes on of different filaments, but these being the most common, just wanted to start there. So from here, I'm going to go forward. You decided to pick up a printer. You went down to Micro Center, grabbed yourself one that looked good to you. You bought a couple cases of different colors of filaments that you thought you wanted. So you get home. So how do you print your first product? So that's what I wanted to step through from here on forward. So your first thing is to get the printer set up. So in addition to getting out of the box, putting it together, plugging it in, just like you would any other computer or printer. A couple of things you're going to do before you even start printing your product is, first off, select which filament you're going to use, load that filament in through your hot end. So you're going to put it on top. You're probably going to heat the hot end up to get the filament to start coming through, just like you would, like I said, a hot glue gun. You're going to plug in your hot glue gun, wait for it to warm up, and start putting your glue stick in to get it loaded. And then your build plate. Your build plate, you just put it on, you threw it together. It needs to be completely level to the tool path, so that way as your head is moving and printing your object, it's not moving closer and farther from the build plate. So most printers are going to come with a SD card that has kind of some setup toolpath codes, such as a bed level program. So a bed level program, you'll turn it on, you'll press start, and it will run similar to what you see on the right. It'll run and print a 1 layer thick square at a couple of critical points on your bed, on your build plate, every corner, center. And from that, you can look and see where your bed might be too low, might be too high, and there's manual adjusting screws on the bottom of the build plate to raise and lower the bed to make it level. So your filament is loaded. You've printed 1 or 2 or 3 bed leveling programs. Your printer is now leveled, loaded, and ready to print. But what are you going to print? You have an idea of something that you want to exist. Best thing to do is to start and see online and see if it already exists. So there's many different databases online that you can search for. Thingiverse being the one I use most often. You go on there, you just search like it's a Google engine, search for Yaesu or Toyota, whatever you're looking for, press search. It'll come up with all the files that somebody else has already designed and went through the effort to build up in their software, and that it's all open source. There are ones out there that the designer can sell it, so you have to buy the file, and but there are almost endless free options. The one time I've actually bought an STL file was, like I said, when I used TPU for that phone case. I wanted to make sure it was exactly for the iPhone 12, iPhone 10, whatever the phone was, and specifically made for TPU filament. So it was a very specific need I needed. Couldn't find it anywhere in the free file, so I found one that a person was selling for $2, paid for it, and it worked perfectly. So I throw out the term STL before I go any further. STL is the most common file format for a 3D model, for 3D printers. So STL files are what people are going to export their CAD software 3D model into in order to share it to other 3D print people. So like I said, those can be developed using CAD or any other 3D modeling software. I use AutoCAD, Fusion 360. There's Google SketchUp. There's plenty of other 3D printing, 3D modeling softwares out there. But for most people, you can go on to any of these sites, find an existing .stl file that already exists and download it and not have to worry about any further modifications. I will add, you can also download an existing and then modify it in a 3D modeling software. For example, that Anytone mount I showed previously, the blue one, that is actually 2 STL files I found on Thingiverse that I put together. I found the mount for the Anytone, I found the RAM ball mount on the back, and I grabbed those 2, just put them together in Fusion 360, and then pushed out a new STL file. So you went on Thingiverse, you found the specific thing you wanted to print, you pressed download, downloaded this STL file to your computer. Now you need to prepare that file for your specific 3D printer. So STL files, like I said, is a file format for storing a 3D object. It needs to be then converted to a specific programming language for your specific printer. Whatever printer you chose to buy, they all have their own proprietary language. So this does require a software. It's called Slicer software, and it does exactly what you think. It's slicing that object into layer by layer by layer to put it into a language that your printer can understand. There are many different Slicer software out there. They're all free downloads. I use Ultimaker Cura, and I'll go through a demonstration at the end of this presentation. But essentially, that Slicer software is going to take your STL file, put it into a 3D rendering, and then allow you to adjust all of your print settings for your printer. So I listed a few of the important ones here that you're probably going to adjust every time, and you might print, and it's not going to work because you need to go back and readjust one of these print settings, being temperature. That means your build plate could be heated. So build plate temperature, as well as your hot end, your nozzle temperature. If your, like I said, if your filament is ABS or ASA, it needs to be a much higher temperature than if you're shooting PLA or PETG out of your nozzle. Print speed as well. The faster you go, possibly the definition might go down. Depending on the capabilities of your printer, you might want to slow that down, or if you've upgraded your stepper motors or your logic chips, then you can up that. Infill. 3D printers call this infill, and that is the actual material on the inside of your object. So think of your object as this hollow ball, but if you don't want it to be hollow, you're going to have a percent of infill on the inside of this ball. So you can choose, you want it to be 10% infill, 50% infill, 100% infill if you want it to be a solid, dense ball of plastic. So you can select a percent infill as well as what kind of pattern. You want it to be in one direction, both directions. So that's an important setting that you want to decide as well. Another one is support material. So if you think about how your object is printing one layer at a time off of a build plate, if your object you want is a hook, for example, let's say it's some kind of overhang or even like a little table. Let's say you want to print a little tiny table. Well, your printer is going to print the legs as the legs grow up off the build plate, and then it's going to try to print that first layer of your tabletop. Well, as soon as that molten plastic leaves one of those legs, it's going to fall because it has nothing to sit on now. So it needs something to temporarily support that layer while it starts printing. So support material is just that. It's the printer is going to build this material on the inside of or the underside of this table at a very light density and with a gap at the very top, so that when that first tabletop layer prints, it is gently supported by support material, by other plastic, but not bonded to it. So that way, when your print is complete, you can pull it off your build plate, and the support material should easily just snap off the bottom, and your table is straight. Last important setting, layer height, which I would equate to as your resolution. So how tall do you want each layer to be? You want it to be half a millimeter? Do you want it to be a quarter of a millimeter? Do you want it to be so tiny that you could barely even see the layer? And that'll determine how fine each layer is, so how fine a resolution. So you want to see the layers. So once you adjust all the print settings as you see fit for your printer, or what you think will work, you're going to save that product, and that'll export out of your software as a G code. And G code is the actual code that 3D printers read off of. So if you have ever used any CNC type machining, you'll probably recognize G-code because CNC uses the same term. It's just the programming language that any machine that's ran off of a computer uses. So that G-code is basically going to list the commands in a certain order that that machine needs to follow. Everything such as setting the temperature, using the tool path, so where this tool needs to go, where it can't go, all of the X and Y movements for this entire product, and then when the print is done, where does the tool need to go and how does it shut down? So everything from start to end will be in this G-code file that comes out of your slicer program. So you have your object, you download the STL, you went into your slicer program with it, and you adjusted all the settings for your specific printer, exported to a G-code. Now it's time to put that into your printer. The most common ways, you'll either have the printer plugged straight in with a USB cable like you would your traditional paper printer. You could save that G-code onto an SD card, a micro SD card, or just a regular SD card, and most printers have an SD card slot where you'll put it in that and use the interface on the printer to actually select the file out of that card and press print on there. Or third option is send it to your printer through the internet, which is the setup I have. It does require a second printer, so a printer to always be plugged in via USB to, or second computer, sorry, to be connected to your printer. So the setup I have is I actually have a Raspberry Pi that is dedicated to the printer. So it is connected to the internet and it is USB connected to the printer, so I can send things to the printer wirelessly. So it's in your printer, start your print, and then the important step is to watch your print, at least the first layer, just to make sure that everything is going correctly, that you don't have any issues, the temperatures are right. Because usually if something's going to happen, it most likely might happen in your first one or two layers, either adhesion issues or a clogged filament or your temperature isn't right. Which leads me to my next one, troubleshooting. Troubleshooting is guaranteed to happen if you're going to get into 3D printing. It's part of the hobby, I would say, but it is usually resolved within a few actions. So some common issues you'll run into: adhesion to your build plate. So your product is not staying stuck to your build plate. Either it's getting lifted up, or it might have just come off altogether to where it's no longer on the build plate anymore, and now your printer isn't printing on anything. It's just shooting plastic in the air. Or warping. Warping is what you see on the right side here. So where maybe the first layer did print fine, but then the second layer, it came on hot, and then as it cooled, that thermal pull, as a hot product gives a cold product, lifted that corner off because, again, you don't have good enough adhesion on that corner. Stringing is what you see on the left here. It's building, like I said, those two legs of a table. So it's building up this one, that's going to go up and build this one, and it's going to go back and forth, and it seems to be just dripping a little in between each time. That could be something as simple as you're just not retracting the filament before each one, and that's another setting you can do in your slicer program. Other problems: your nozzle can get clogged. You forgot to put supports on, and it's going to try to do the tabletop and just start spitting plastic all over the side, or you're going to run out of filament in the middle of the print. And hopefully your printer has a out of filament sensor to where it'll pause. But either way, it means you need to put new filament in and hopefully be able to continue your print without any glitch. Overall, most issues you're going to run into are going to come down to either a setting in your slicer program. So you're going to go back and turn up the temperature or turn down the temperature. Maybe it's too hot, too cold. Just play around with it. Maybe you're going too fast, so maybe you slow down the speed of your print head. You forgot to add supports, so you need to add supports, or the infill wasn't enough. You need to increase your density. So lots of different ways you can go back and trial and error. And again, that's part of this, and that's why PLA, low cost. You can print it multiple times to get it right. And usually once you figure out the unique intricacies of your own printer, you won't be having to go back and forth as often. It could also be a printer hardware issue. Maybe your build plate is just getting too old. Maybe you've printed on it too many times. It's just wearing out. Nothing's going to stick to it anymore. Same with your nozzle. Your nozzles are going to wear out over time, so you're going to have to replace the nozzle. Maybe your bed is no longer level, so run another bed level test and readjust because those will start to settle. Or yeah, your filament ran out, so your roll is empty. Also, your filament material itself. If you bought a low quality of filament, then maybe it has an inconsistent size. So we got thicker and thinner by just a fraction of a millimeter, and that was enough to mess up the print. Or it's just got dust, a little bit of dirt and dust on the filament, and that clogged up your nozzle. So keep your filament rolls clean and in a clean place. Or temperature requirements. You threw in ABS, and in your slicer program, you still had the PLA settings. So 180, 200 degrees just wasn't enough to melt the ABS. So you need to go back and, again, adjust your slicer settings. So any filament you buy is going to give you recommended temperature and settings on the side of the roll for that specific brand and type of filament. Okay, so you went through all that, you printed your product, maybe it messed up and you had to go back and adjust some settings, and you sent it back to the printer and it printed just fine. So the printer spits it out, it's cooling off, so you're able to take it off the build plate. So there's going to be some post-print that you're going to need to take care of. If you have support material, you're going to have to remove that, and sometimes that's easy, sometimes it's just on the bottom of the table. Sometimes that support material is in a really tight little inside hole that you have to get in there with a needle nose or tweezers or razor blade and be able to get that out, because you wanted to make sure that that bolt hole was an exact circle and it was way in there. You're going to want to assemble your parts. Maybe being a 3D printer, the build plate is not big. You're about limited to a 10-inch by 10-inch square of build surface area unless you buy a bigger one. So a lot of times ways to get around that for bigger projects is you're just building them in pieces, and you can assemble them. Either they click together or super glue or other fasteners that are built into the print file. If you want a clean finished product and you don't want to see tiny little layer lines, you can sand those smooth and prime and paint, and you'll never know that it was a 3D printed product. And just a sharp razor blade or a scalpel is your best friend, just to clean up some little goops on the edge or on the sides where the nozzle just had a little bit of a hiccup, just to make your product a little cleaner. And you might have to test fit. And maybe you printed it all and you thought it worked fine, and you put your radio in the mount and it doesn't fit exactly right. Maybe you had some shrinkage. Either your printer did it or the person who developed that file just didn't account for that. So you can go back into slicer settings and just type, enlarge by 101%. So it just grows it a little bit, just to adjust the size a little bit to fit your specific need. Any questions from the slides so far?
I'll just interrupt you for a second. Jeff's
Sure.
put the drawing information in the chat. So if you're a member and you want to enter for the drawing, we'll go into the chat and click on the link and do that. We'll draw here in a bit. Go ahead, Josh. Sorry.
Okay, sure. So from here, I'd like to just go through a quick, what I just talked about, that whole process. We can go through a step-by-step and show you how that works, and show you one that's actually currently printing on the printer right now, just to put all those words. I'm more of a visual learner than a word learner. So let's say, we'll go here to Thingiverse, makerbot.thingiverse.com, one of those links that I put on the file, and let's find something for Yaesu. So I'll type in Yaesu. Here is all the things. You could be more specific than just Yaesu, but FT817, little Anderson power pole adapter, remote mounts for 857. So there's a whole bunch of things here. So let's say, I want this base cradle for my FT2. So I'll click on it. Usually they'll give you some good pictures. You can get a good view, see if it's something that you want to print before you take the time. Say, okay, I want to print that. You can come down and read. They'll tell you a little summary of what it is, why they did it. And usually the most important thing is you're going to come here and see their recommended settings. They'll say they use this printer. Doesn't really matter that much, but they'll say, yes, you do need supports. I printed it at this resolution. That's the layer height, 0.2 millimeters. and I use 20% infill. Those are all pretty standard. 0.2 is just the standard resolution. 20% is your starting infill. Rafts is basically if you have adhesion issues, you can have your printer print basically a base, like a stage first, before it actually prints the product to make sure you absolutely don't have any adhesion issues, to make sure it's absolutely level. You basically get all that out of the way with this sacrificial raft that you build under your object. So you can go through here, look at comments and stuff like that, but I'm going to go here to the file. Looks like he did an update. He rotated it. So if I go to the files, you'll see he included F3D is a file that I can bring into a 3D modeling software. So I'm not going to mess with that right now. Here's the STL file, but he said he did an update. So that's this one, version 2. He updated July 10th. So, okay, that's the file I want. I'll go ahead and click download on that one. Okay, so it's in my download folder. So once it's downloaded, I'll go to my slicer software, like I said. So I use Ultimaker Cura. This is the slicer software. So this is where you're going to download whichever slicer program you want, put in what printer you have. So I have the Creality Ender 3. I'm using just a generic 0.4 millimeter nozzle, which is plain PLA, nothing fancy. And I'm going to find that file we just downloaded. So there it is right there. Okay, so that looks right. That looks like the base, the cradle we just saw on Thingiverse. So we're getting close. So now here are all the settings that you can adjust. So he said the resolution of 0.2 millimeters, and that's standard. If you wanted your layer height to be 0.16, 0.12, much finer quality, you can, but it's just a base for a radio. I don't think it needs to be too. Okay, and here's where you can adjust pretty much any parameter, and I would recommend keeping it at its default settings unless you want to play around with some of these settings. But you can adjust the thickness of specific areas around your object. Infill, like I said, this is where you would want to, if you want to make this super dense, you can up this to 100%, make sure the inside of this object is 100% plastic the entire time, 100% PLA or PETG, whatever you are printing. I'm going to keep that 20% just to make for a faster print. You can adjust the pattern. If you want to do it in grids, triangles, there's a whole bunch of different patterns. And those just basically, they give you a little description here on what those each do. Reduce material cost, increase strength. So depending on what you want, we'll keep it at zigzag. Your temperatures you're going to get off of your PLA, your filament roll. They're usually going to say for PLA around 210 to 220 degrees Celsius. I've just been doing 213. It's been working great for me. And same with my printer. I run my build plate at 60 degrees Celsius. Some people do lower if they're in enclosure. Some do higher for a different type of printers if it's a bigger build plate. But this seems to be working well for my printer. The print speed is what's going to really affect how long this is going to take to print. So I have it where the head of my printer will be moving at 100 millimeters per second while it's going through and printing this. And that's because I've upgraded the stepper motors a little bit and the brain, the computer of it a little bit to be able to handle a little bit faster speed. But typically 70 to 80 millimeters per second, it'll be a good print speed. Retraction. So this is where you saw the stringing troubleshooting. That might be because you're not enabling retraction. This basically means when it's done with a layer or when it's trying to go around a hole or moving around to the next piece of the print, it's going to suck the filament back up just 3 millimeters, just so that way it's not just dripping out while the head is moving away around the printed part. And I make sure you avoid the printed parts when traveling. I don't want the head to break off a tiny piece or possibly break adhesion with the build plate. So a lot of settings in here. Support. So if you want support, go ahead and check that box. Where do you want it? Do you want it only where it touches the build plate, so everything between the build plate and your object? Or do you want it everywhere? Everywhere is going to mean it's probably going to be inside of each of those little holes as well, and that's going to be a pain to clean up. And most of the time with holes, in my experience, I don't need support material because it is a gradual cross, and usually by the time it gets to the top, it's fine. So I'm actually not going to use support on this print, but you can turn it on, you can tell it where, and you can tell it to turn on for anything after 45 degrees. So my printer does fine up to 45 degrees, but once it gets past that, you need to start putting support material or anything, any other slope that you decide. So I'll turn that off. And your build plate adhesion. So you can add other features, like I said, the raft type for increasing your adhesion. So a skirt, it actually says it all here. A skirt being it puts one line around it. I like the skirt just because it gives me one last check of the bed leveling, so I can watch that first line around the print to make sure, okay, it is definitely level. It should be good to go. A brim adds just a single layer under the object just to make sure you have good adhesion. And a raft, like I said, is an actual built-up stage, usually 4 or 5 layers tall, that gets built up first before it even starts your project. So we'll go ahead and say no build plate needed. There are printers out there that have dual extrusion. That means either the head has 2 hot ends or you have 2 heads on your printer, and that could be handy if you want to do 2 different colors in your print, or you have the option of also printing your object while using support material with your second head. Why you would do that would be they sell water-soluble filament. So you can put a water-soluble filament in your support material head. That way, once your print is done, all you have to do is put your print in water and all of your support material will just melt away. So sounds nice. I don't have a dual extrusion, so that's never been a feature I've used. So you get all the settings in. You think you got it right. You're going to tell it, go ahead and slice this object. So it's going to think, it's slicing it all out. Okay, it's done. It's going to take 2 hours to print. It's going to use 21 grams of filament, which 2 hours might seem a lot, but compared to running to HRO and back, 2 hours isn't that bad. So I'm going to go ahead and save that file. I'll just put it on my desktop. You can call it something. I'll call
Josh, can you show the preview?
Yeah, I can. I'll just save on here. So 2 hour FT2 cradle print. So I'll save on desktop for later. There you go. File save. Yeah, so here's the preview. So here you can play through what the printer is going to do. Oh, you go. So all the way down. Let's go to the very bottom. So the printer is going to, it'll actually show you the toolpath, how it's going to print. And it's pretty slow, but we'll drag it out. So it's going to build that whole bottom, just like that. And it's going to keep building up layer by layer. So the base will get built. Then it'll start the walls. Make sure to work around all those holes for the speaker to still work. And then finish up at the top with a nice taper. And that's essentially what your printer is about to do. So you saved it. And from there is where you would grab that G-code file. I saved the desktop. Go ahead and either put that in the SD card that you're going to put into your printer, or you're going to send it to your printer via a USB cord, or like I said, mine is connected. So here is my printer actually printing that right now. So I came over here, I dropped the file in here and told it to go ahead and print. So in here I can see here's the tool temperature, here's the bed temperature, and I can adjust those from here. I can see on the webcam how the print is going. Here's the skirt. I showed you the one line around the base just to make sure that it was perfectly level. And I can adjust things, turn the fan on more. I'm not going to touch it because the slicer program I felt was good settings. And you can actually see the G code that we just talked about here. So here is the current layer, how the tool is going through. And we can do the same thing here. We can see how it's doing every single layer of the print as it goes through, all the way to end product. And that is it. So it's still 50% done. So it still has an hour till it's done. But when that's done, the printer will shut off and spit it out, and I can pull that off the build plate and hopefully just slide the FT2 right into it and have a solid mount to put it in. That's all I had. Anybody have any questions or anything else they wanted to look back at?
Any questions, anybody?
You did a great job.
Thanks.
How do you get it off of that? How do you get it off of that base? It just.
It's yeah, so it's pretty well adheres to the build plate. So most printers come with a tiny little spatula. They'll actually you'll pry under it and get between it to pry it off. And as soon as you break the adhesion a little bit, the whole thing is, because it's a rigid plastic product, so it'll come off.
Okay.
This build plate that this printer is currently printing on is a magnetic flexible bed, which is very nice because then all I have to do is pull this thing off that's magnetically put on and just flex the, it's basically like a stainless steel flexible build plate. So I just bend it a little bit and this rigid plastic just pops off because it doesn't want to flex with the plastic, with the metal. So yeah, adhesion is probably going to be your biggest enemy with 3D printing. You're either going to buy a different type of build plate that has good adhesion. Some people use glue sticks or a blue painter's tape just to try to make a more abrasive surface. And the more and more you use your build plate, the less and less you're going to lose that adhesion property, and you're going to go through build plates eventually.
Okay, interesting. Any questions, anybody at all?
Yeah, I prefer use a pane of glass that I got at Home Depot, and I like Aquanet.
Oh yeah. I've heard good things about glass too. I wouldn't try bending the glass, but
yeah. The question for using the Ender, and one thing I haven't done is ABS. Like, aside from getting the enclosure and venting it, is there anything else you need to do to be able to print ABS? Because I'd say that's, like you said, when you put stuff in your car, that's the biggest downside. PLA is really easy to print with, but for a lot of things, ABS or something like that is going to be where you need to go. Or is there an alternative to ABS that you don't have to deal with toxicity?
ABS and ASA are definitely, I would say, hand in hand on their strength and UV resistance and temperature, but they both have that toxic fumes that you need to deal with. One thing that I'm experimenting with right now is actually, I was playing with it actually for that ham radio faceplate mount in Dad's Dodge. Is a heat treated PLA. So it's still PLA, so you still print it as such. It has carbon fiber built, tiny bits of carbon fiber within it, and after the print, you actually put it in the oven to anneal it, and it actually just kind of bonds all the parts together and changes the chemical composition of the plastic to heat treat it up to over 200 degrees. So that seems to be working so far. I haven't gotten too far into ABS because of the reasons you just said.
And that piece in the Dodge here this summer, it got really hot in there, and so far it's holding up just fine.
Yeah, so we're playing around with different options. PETG did good too. That's the blue anytone mount. PETG is slightly higher, so I see a little bit with that flexure, but definitely not as bad as PLA. But the heat treated PLA was good. PLA Plus also helps a little bit. But really, nothing's going to beat ASA or ABS. ASA, I've heard, has better UV resistance as well than ABS. So that seems to be the new go-to if you're going to go that route.
Okay. Any other questions? So we got 13 in the door prize, Ben. Anybody?
One more question.
Sure, go ahead.
So I've got the 3D, the Ender 3D Pro, and I added the, I think it's called the BL Touch bed leveler.
Yeah.
And it just doesn't seem to work very well. Do you have any tips on, I don't know what your experience has been with bed levelers, or do you just do it manually?
Dad, do you want to jump on this? Because he has the Ender 3 with the BL Touch. And I've heard
it's
things
a pain.
from him.
It's a pain. I have gone rounds and rounds and had limited success with it. I hear the V2 has it built into it, and it's already built into the factory code. I have the bed leveler on my CR10, and it works great. But the Ender, for whatever reason, it's just easier just to do it manually. So I disabled it and I just use it manually now. It's a pretty little thing that glows off to the side now.
Yeah, right. Well, I heard from a buddy of mine who's got a capacitive one, and he swears it's better, but it's expensive, like all the other upgrades are. But
Exactly.
okay. Thank you.
Okay. Any, how are we on the drawing, Jeff?
Still sitting at 13.
Sitting at 13. So last chance to get your name in for the drawing. Just still remind you again, the Ham Fest, and bring a friend, bring a non-ham, maybe somebody interested in ham radio, or just get them indoctrined a little bit.
We can still use some
And also we'll
volunteers.
have VE test, be VE testing at 10 o'clock. So we'll test for Tech General or Extra, I believe.
Josh,
And
Jerry, are we still need volunteers?
I don't know. Let me ask Kathy, how are we on volunteers? Think we're okay?
All right, cool.
She thinks we're okay, but I'll tell you what, it doesn't hurt to have an extra.
Yeah.
So if you would be interested in volunteering, go there again. Go to the DRC Radio Club Ham Fest like before, and then scroll down. There's excuse me, a volunteer box there, and if you don't know what you like, just put in. You do anything. It's fun, and you're just gonna occupy not a whole lot of your time. You'll still have plenty of time to walk around and look at stuff and all that. And if we don't need you, we won't use you. So it's always good to have more than less. Okay. Excuse my voice. Well, Jeff, I guess unless we got anybody, you're still at 13, spin it.
And here we go. Randomized range. Looks like the winner is Chris McCall,
Chris?
AE0RH.
AE0RH. Okay. Oh, congrats. You'll get a $25 HRO gift certificate in the mail and in a day or two. So congratulations.
Well, yeah, that's fantastic. Thank you.
Okay. Use it well. All righty. Well, Josh, hey, thanks a bunch. That's very interesting. I'm sure I've always thought about that. Same thing was, the engraving and all that with the other. So pretty interesting stuff. So I noticed there's an outfit called Banggood that I get a daily thing, and it's they have the printers in there. Now whether they're any good or not, I don't know. They're obviously Chinese, but you're probably better off dealing with the Micro Center or somebody local if you got an issue, I would guess. So again, thanks. Any final questions, anybody, or comments, or with that? If not, we will call it a night. Thank you.
I appreciate it, Josh. One thing I guess is specific to radio is, have you ever made like CW paddles? And
No, but I've seen them on Thingiverse. Yeah.
okay, yeah, I was just wondering if there was a certain file that works better than others, because I think that's one of the things I'm going to attempt.
Okay. Well, let me know if there's anything that needs to be tweaked. That's the thing with these things. Is usually you can find something that's close, and you can always pull it in and adjust and make it your own.
Okay. Well, thank you. And I guess we're done. See you at the Hamfest.
Thanks, everybody. Thanks, Josh.
Thanks.
Night,
Thank you,
night,
Josh.
everybody.
Yes.
Take care.